So we're going to do some chemistry homework today. We're looking at video 223. You're in the right place if you think that's here. So let's make a start straight away. And we're just focusing on questions to do with the periodic table. Okay, so this goes from both 2.1 and 2.2. Our first question then. Magnesium and calcium are in group 2 of the periodic table. They are less reactive than the metals in group 1. Okay, calcium reacts to form calcium hydroxide and hydrogen, and then we've got an equation. Describe what would be seen. Now, the first thing I've said here is that the metal sinks to the bottom, and the reason for that is that metal is more dense than water. Okay. My second one is that bubbles of hydrogen gas are produced, and I've got that from there. See where it says bracket G? That means it's a gas. We've got a solid, liquid, and a solid. So if it's a gas, that means we're having a bubble produced. Magnesium reacts very slowly with cold water, but it reacts faster with steam and forms magnesium oxide. They've given us an equation here. So we're going to form MgO, and we know that it's H2. So all I did at first was I wrote out my equation, and then down the bottom here I'm just balancing it up. And it's quite nice one actually, because it shows that it's balanced on either side. We don't really have to do a lot to that one. Just be careful. Hydrogen is what we call a diatomic molecule. So they never found on their own, they're H2. Your other ones are things like N2, O2. Then you've got all of the halogens. Okay. And they form kind of like a 7 on our periodic table. It's on the right hand side. So you'd have N, O, F, Cl, Br, and I. And then obviously we've got little H2, which sits in the middle of your periodic table. Okay, the electronic configurations of magnesium and calcium are 282 and 2882. When magnesium and calcium react with water, they form positive ions. Suggest an explanation in terms of the electronic configurations. So these ones, why calcium is more reactive than magnesium. Okay, so first of all, bit of a walking, talking marks here. We got 2 questions for you. Calcium and magnesium react by losing the 2 outer shell electrons. So you can give yourself 1 mark if you've written that. Now, if we're looking then, calcium is more reactive. It's got 1 more shell full, hasn't it? Now this shell, it shields the positive attraction and it increases the distance. So it's easier to lose those 2 electrons. So that's your second mark. Okay. Now we've now got an empirical formula one here. And we're looking for information. So first thing I've done is that I've put a column and I've got Ca and I've got Br. And I then need to now work out the number of moles for each one. N is equals moles. And our equation is M over Mr. My M is from the question. Okay, so for bromine it's 0.8 and for calcium it's 0.2. And then I've got my Mr here. And the Mr, all it is the atomic mass from the periodic table. I've then worked out the number of moles and I've put them in standard form, okay, so it's easy for me to see which one is bigger or smaller. I'm going to circle that smaller number, the smaller number of moles. I'm going to divide both sides by that. So 5 divided by 5 is 1, 10 divided by 5 is 2, which then gives me my empirical formula of CaBr2. Question 3 here then, we've got periodic table and we've got A, B, C, D and E, okay? These are just made up elements. Don't be confused if you're looking at your periodic table, they're just symbols for them. So, give all the letters of the elements that are metallic. Well, I've put A, B and C. And the reason for that is because if we remember when we looked at the periodic table, there's kind of like a staircase which runs from group 3, where by boron, and it goes all the way down to the bottom of group 7, which is AT. Okay, everything on this side is a non-metal, and everything which remains then is a metal. Okay, and just write that in nice black so we can see that better. Non-metal. Give the letters of the two elements that have the most similar chemical properties. Well, A and B, they're in the same group. They're in group 2, so they're both going to have 2 outer electrons. So they're likely to have similar reactivities, aren't they? Finally, an atom of element B contains more protons than element A. State how many more protons there are. Okay, now there's two ways of thinking about this. Okay, I know I can just count from side to side how many more, because I know every step to the right from A will be one more. So I could just count 1, 2, 3, 4, 5, 6, 7, 8. Okay, or I could just go a period down, and if I've gone a period down in the same group, I must have gone 8 elements, so it's just going to be 8 more. The only exception to that rule, let me have a think. No, there isn't. Is there an exception? I'm just looking at my periodic table. Yes, the exception to that rule would be if I was going from hydrogen and I went downwards, it wouldn't work, and it'd be the same. No, it'd be just hydrogen where that rule doesn't work for, okay? Because obviously it goes 1, 2, because we haven't got anything in that group. Okay, an atom of element E has atomic number 10 and mass number 22. How many electrons does this atom contain? Well, your atomic number is your protons, and your protons always equal your electrons, so it's going to have 10. Okay, this is an interesting question. There's another one like this. This is an exam question. They love asking this. And it's because if we think the classic one of this is chlorine is 35.5 on the mass number. Okay. Now what they're asking is that some other elements do have decimal point mass numbers, because that is a mean. Okay. And it's based on the relative abundances of all of the different atoms. Okay. So I've got 90% is a mass of 20, and I've worked that out because I know 10% is 22. And I'll just highlight that key information for you. Okay. The remainder is 20. Now all I'm going to do is I'm going to do this times this, this times this, put it in brackets, just to make sure that you are not having any mistakes on the calculator. Then just divide it by 100, and I'm going to get a percentage almost, because I've got 90 and 10, which is then going to give me 20.2. Okay. The element E in the periodic table is used to fill filament lights. Explain why this element is for this use. If I look at E, he's in group 0. Group 0 then, if we're thinking, it's a noble gas, isn't it? Making it inert, which is a nice scientific word for low reactivity. This means that the spark won't set the gas alight. Okay, let's find the final couple of questions then. Elements in group 2 of the periodic table are boron, aluminium, gallium, indium and thallium. Explain using its position in the periodic table whether indium is a non-metal or a metal. So it's in the transition metal block, making it a metal. Just another quick reminder, we've got our staircase, haven't we? Indium sits there. It's this side of the staircase, which is the metals, okay? Each aluminium has 13 electrons. State the electron configuration. I'm thinking here in words of my electron configuration. So I've got 2. I can then fit 8 in the next one. I've got 10 left over. And then I've got 3. Okay, so I'd be looking at 2, which is my first shell, 8, which is my second shell, 3, which is my final shell. Boron has an atomic number of 5. There are 2 isotopes of boron, boron 10 and boron 11. Every boron atom contains, well, my atomic number of 5. This atomic number, we're talking about protons, aren't we? And then these differences here are to do with the mass number. So if it has an atomic number of 5, I know that it's got 5 protons. Okay? To explain what is meant by the term isotopes, classic definition here, same number of protons, different number of neutrons. And they've given you that classic example of chlorine 35 and chlorine 37. So skinny chlorine and a bit bigger chlorine. A sample of boron contains 2 isotopes, boron 10 and 11. But the relative atomic mass is 10.8. This 10.8, that's what we just calculated before, where we got 20.2. Give the reason why the relative atomic mass is closer to 11 than 10. Well, it's just because we've got more 11. Okay? So on average, it's more likely to be an 11 than it is a 10. So it's closer to 11. Okay. There's a bit of data task here then. So complete the table to show the relative mass and relative charge of each particle and its position. Well, I did forget to do this one beforehand, but we'll do it now. It's got a proton, its relative mass, if we remember, it does have a mass. It's the same as a neutron, it's 1, and it's in the nucleus. He's in the centre, because it's always positive in that centre. Electrons, if we remember, we've got neutrons first. Neutron stands for neutral. If you're very neutral, you're neither really happy or sad, you've got a charge of 0. Then electron, they don't weigh a thing. Relative mass is 0. And they're always a bit down on themselves. They're always negative. So we've got a relative charge of 1. And finally, a bit like the planets orbit in the solar system, the electrons orbit the nucleus in shells. Complete the sentence. So an atom of an element always contains more protons than neutrons. We know that's not right. We've seen that. Just a perfect example for you is boron. And if it's 11 and 5, because it's got 5 protons and 6 neutrons, so we can say that's wrong. Equal numbers of protons and neutrons. Well, boron 5 sorts that out, doesn't it, for us? An atom of an element, more electrons and protons there, it's going to have a charge, isn't it? So that's going to be an ion, so it's not that one. Remember, our atom is always equal. Okay, so let's square him there. Okay, symbols for some atoms are given in the box. This is just work off your periodic table now. Okay, so calcium is always in group 2, we know that. And an atom that forms an ion with 2 minus, that means it's in group 6, because in that outer shell, and I'm just going to put atom, if we think for this to be full, I need to gain an atom here, an electron here, an electron here. So I need to gain 2 in total. So if I draw those in red, my new electrons, that's going to give me a charge of 2 minus. My only atom there, which is in group 6, is oxygen. So I've picked that one there. Okay. State the total number of atoms. This is just a case of you looking at the bracket. We can get really caught out on this bracket here, but just remember that little 3 times is everything in there by 3. What is the most likely formula of aluminium nitride? Now, nitride, it just means nitrogen on its own, okay? And nitrogen, as I have written there, forms an N3 minus ion. Now, aluminium, if we just go down here, I've done the crisscross method, it forms a 3 plus, and we've got a 3 minus. I'm going to crisscross, so I've got my 3 this side now, and my 3 this side. I could really have Al3N3, couldn't I? But that's not the simplest way we can represent this ionic compound, because we haven't got the ratio down to the minimum. So 3 goes into 3 either side. So we'll divide both sides by 3. Gives us 1. So we have ALN. And I've written that with... I just crossed him. Okay. Last question then. Nice little table again. So we've got 6 different particles here, and we've got some information on them. So we're looking for which is a negatively charged ion. So I've stated we need more electrons than protons here. obviously, if we're looking through, we're just looking at this difference here. So we got the only one, if I see T, yeah, T's got 18 electrons and 16 protons. So that's our negative one there. Which particles are atoms of metals? Well, we're looking really now at the position in the periodic table. Okay, and I've cross-referenced these. I've used the number of protons in Q and S to find the atomic number, and then I've gone and I've looked for the elements which are this of our staircase. They are this side. Okay. Say what's meant by atomic number. Number of protons in the nucleus. Bit of a just extension. In atoms also means electrons because they are equal. So the atomic number of boron is 5, and boron exists as boron 10 and 11. Why are they isotopes? Well, both have 5 protons. Boron 10 has 5 neutrons, boron 11 has 6 neutrons. So they've got same protons, different neutrons. And finally, a sample of boron contains 19.7% of boron 10 and 80.3% of boron 11. And we're just using this calculation again, okay? So I'm going to do the percentage times the mass in brackets plus the other percentage of mass divided by 100. And again, and this is using relative abundances, okay? And there is your homework. So if you can rewind, pause, just make sure you really understand things, okay?